By layer from bottom to top, creating a physical object. The printer spreads a thin layer of powder over the previous layer, and the cross-section of the part is then printed using a standard HP printhead with a liquid binding material, essentially glue, to complete the layer. Once one layer is finished, the tray lowers and the process is repeated until the part is completely built. Once the entire build is completed, the part is taken out of the machine for post-processing. The part is moved from the Z-Core printer to a depowdering station to remove any remaining powder. The depowdering station has a compressed air gun used to blow off any excess powder from the part. Once the excess powder has been removed, an infiltrant is applied to the part's surface that soaks in and provides additional part strength. Z-Corp's 3DP process is great for pieces that have pictures, graphics, or other color data on the surface. Just like your 2D desktop color printer, the printer has 3 separate print heads for each of the standard printer colors: magenta, cyan, and yellow. These combine to allow for full color 3D parts. The Z-Core process is ideal for showpieces such as architectural models. The Z-Core printer allows for scaled architectural models to be built using detail and color schemes. It is also used for medical models, 3D concept models, character models, topographical mapping, FEA analysis displays, as well as form and fit prototypes. For example, this part is considered a communication tool. The coloring pattern is the result of an engineering stress analysis that can be used to help visualize.
What we do is we inert a large chamber with nitrogen, and a 70-watt CO2 laser imprints the image of each layer into the powder by melting it.
Anh hề đi còn sử dụng ấy anh nhỉ. Tao là
same fashion as other layer additive manufacturing technologies. A program takes 3D CAD data and mathematically slices it into 2D cross-sections. Each of these sections will act as a blueprint, telling the DMLS machine exactly where to sinter the metal material. The data is then transferred to the DMLS equipment. A recoater assembly pushes powdered metal material from the powder supply to create a uniform layer over the base plate. A laser then draws a 2D cross-section on the surface of the build material, heating and fusing the material. Once a single layer is complete, the base plate is lowered just enough to make room for the next layer. More material is raised from the cartridge and recoated evenly upon the previously sintered layer. The DMLS machine continues to sinter layer upon layer, building from the bottom up. As the part is built, support structures are added to give supplemental strength to fine features and overhanging surfaces. The completed part is then removed from the base plate and treated with an age-hardening heat process to further harden the part. Any support structures are also removed at this time. With numerous surface treatment and hand polishing options available through service providers such as Solid Concepts, DMLS parts can be used in highly cosmetic applications. Typical uses for DMLS include tools and manufacturing aids, small integrated structures, dental components, surgical implants, and aerospace parts.
Requirements are basically having a laser source. Power range is typically from 500 to 6,000 watts laser power, a powder feeding system and a powder nozzle focusing the powder stream into the melt pool. We developed the system, the metal powder deposition system, in a way that we are offering a technology package. The technology package embraces the feeding system, the powder conduit, the focusing optics, and the powder nozzle. And that technology package can be married with different laser sources, either solid-state lasers or CO2 lasers, and it can be mounted to different machine kinematics, starting from very simplistic machines with 2 or 3 axes to NC-controlled Cartesian machines, robots, industrial robots, to fully integrated 5-axis machining centers. We are feeding the powder into an inert gas stream in the powder feeder. Should mean the powder feeder is a PLC-controlled device, and we can precisely program the amount of powder in grams per minute we are feeding into the powder conduit. The powder, the transportation principle of the powder is friction, though we are using helium as a carrier gas and
final product. Save time and money with the SD300 Pro. Now go from concept to final product without using a service bureau, thus reducing costs and time to market. The SD300 Pro, revolutionizing the way designers and engineers approach 3D modeling. Plug-and-play desktop installation. With the SD300 Pro, operation is made simple using the user-friendly instruction manual provided with the material kit. Install in a matter of minutes. First, insert the engineered plastic roll into the printer. The engineered plastic roll used in the SD300 Pro is both durable and economical, giving you attractive build cost per model. Second, insert the glue cartridge. Third, insert the anti-glue cassette. Finally, place the 3 anti-glue pens. Now just hit the build button on the provided SD View software and your printer is off. Finally, a 3D printer you can afford. The model is created by layers of engineered plastic. Following sheet lamination, the cutting knife goes to work directly from your CAD data. The engineered plastic roll is layered using special glue, resulting in strong yet flexible models. The anti-glue pens then apply masking fluid for easy support removal, allowing even the smallest details to be created. Reducing development costs and time to market. Models are designed down to the smallest detail, and the engineered plastic roll is available in transparent or opaque colors. You now have your finished model in hand, ready for evaluation, without ever leaving the office.
plastic, about 3 millimeters in diameter, rather like a piece of wire. And that filament is fed into a melting head in the machine and then extruded out of a very fine hole. The machine then scribbles with that molten plastic onto a flat plate to make a layer of the object that's to be built. The plate then drops down by a small fraction of a millimeter, and the next layer is scribbled on top of that, and so on until the whole component has been built in 3 dimensions.
Vic Oliver from New Zealand is another member.
So that we can print in new materials and increase the functionality of the printer.
In May 2008, RepRap achieved replication for the first time. This parent machine made a complete set of parts that were then used to build this child machine. The child machine was immediately put to work making grandchild parts. The team are now working on version 2 of the RepRap machine. It is to give away the designs for a machine that anyone can use to make many of the goods that we all currently have to buy. And anyone can also use their RepRap machine to make more RepRap machines for other people. The project aims to put a factory in every home, a factory that can make more factories.
It's a great day, I'm feeling good, oh, the possibilities of what I could, oh, do with the world at my fingertips. My imagination brings a smile up to my lips, oh, fascinated, I'm moving fast, oh, I'm optimistic as the days go past, oh, opportunity is here for me, so come along and take a look because I want you to see. Tomorrow's what you want them to be. You got the power in your hands to shape your history. You gotta take it up a level and go up higher. Put more fuel in the tank and turn up the fire. Come on and take a leap into your destiny.